Picture a silent ember drifting toward the sun, moving so quickly that no gravity well in our system can bind it. That ember, provisionally tagged 3I Atlas, appeared in late June when the Atlas Hazard Survey cameras in Hawaii and South Africa logged a faint, fast intruder. Initial orbital fits showed an eccentricity greater than 1, the mathematical stamp of an origin beyond the sun's reach. We have met only 2 such emissaries before, 1I Oumuamua in 2017 and 2I Borisov in 2019. Now a third arrives, tugging at our curiosity and our instruments in equal measure. The object's present speed is almost 70 kilometers per second, enough to span New York to London in 90 seconds. Backtracing the path leads toward the constellation Lyra. Forward projection shows a swing past Mars on 3rd October 2025, a solar perihelion 20 days later at twice Earth's distance, and final escape by early 2026. Earth stays on the sun's far side throughout, so the risk ledger reads 0. The intrigue ledger, however, is packed. Composition sits at the top of the to-do list. A comet would sprout a gaseous veil as ice evaporates, yet deep imaging has yet to reveal any coma. An asteroid would follow purely gravitational curves, yet a whisper of extra thrust may lurk in the astrometry. The James Webb Space Telescope can cut through reflected sunlight and sample the infrared glow for water, carbon monoxide, or exotic minerals. If the spectrum comes back featureless or metallic, theories multiply. Brightness fuels the puzzle. Even with a modest albedo, the observed flux implies a body several kilometers wide, far larger than Oumuamua, whose size was measured in hundreds of meters. A highly reflective hull could achieve the same luminosity with far less mass, a possibility that keeps technosignature specialists awake. Professor Avi Loeb, already known for suggesting an artificial origin for Oumuamua, is lobbying for continuous JWST tracking to test for non-gravitational acceleration. A persistent drift unaccounted for by gravity would demand explanations that push against the boundaries of conventional astrophysics. Statistics pose the second riddle. For centuries, astronomy recorded 0 interstellar passers-by. Now we count 3 in 8 years. Better sky coverage explains part of the surge, yet simulations indicate the detection rate is still high. Either the density of galactic debris is underestimated, or transient swarms are sweeping the sun's neighborhood. The Vera C. Rubin Observatory, starting full operations next year, will clarify the odds by mapping every moving speck down to faint magnitudes every few nights. Structure forms the third unknown. Light curve monitoring can reveal whether 3I spins like a platter, a spindle, or a rubble pile loosely bound by microgravity. Oumuamua's flattened shape and unexplained kick remain controversial. A repeat would strengthen calls for new physics or new engineering. Rapid tumbling might indicate past collisions, freshly exposed ice, or even deliberate attitude control. That opportunity extends well beyond the object itself. Each interstellar visitor carries isotopic fingerprints of the chemistry that shaped alien worlds. Sampling those fingerprints, even remotely, refines models of planet formation, volatile delivery, and the migration histories of giant planets. In a decade, robotic missions may be fast enough to intercept such bodies. Today, we practice with photons. Time is tight. By September 2025, the object will vanish into solar glare. By the time it re-emerges, the outbound leg will dim below major telescope thresholds. Roughly 5 months remain for the most ambitious observations. Teams are coordinating radar pings, ultraviolet spectra, and high-cadence photometry to squeeze every bit of information from the fleeting visitor. Why should the broader public care? Because 3I Atlas is a tangible reminder that our solar system is not an island, but a crossroads. Somewhere, an unknown star flung this body into the dark, perhaps through a near miss with a giant planet, perhaps through a cataclysmic collapse of a binary pair. After wandering for millions of years, it has brushed past our doorstep, offering a message in a bottle. The galaxy is bustling, and we are part of that bustle. Whether the newcomer proves to be ice, rock, metal, or something unprecedented, its brief appearance renews a sense of frontier. Sky surveys sharpen, theories adapt, curiosity deepens. The next discovery may come sooner than anyone expects, and when it does, the groundwork laid today will allow us to read its story more clearly. For now, astronomers chase a streak of light across CCD frames, and every clear night might deliver a clue that rewrites chapters on planetary science, or adds a footnote to the search for artifacts among the stars. In either case, the sky is not done surprising us. Origin scenarios abound. Some simulations eject 3I from a nascent planetary system after a close brush with a giant planet, while others invoke a crowded stellar nursery where passing stars fling debris across interstellar lanes. Whatever the trigger, the body has drifted for perhaps tens of millions of years, carrying the isotopic signature of an alien chemistry lab. Radio arrays will also listen for narrow-band emissions, more out of thoroughness than expectation. After Oumuamua, techno-signature protocols are standard. Scan, archive, move on, unless a signal repeats. Looking ahead, Rubin's legacy survey of space and time should uncover several interstellar objects every year, identified early enough to permit rapid robotic flybys. Concepts under study at multiple space agencies outline launch-on-alert missions that could sample surface dust or even return grains to Earth. Each discovery thus acts as rehearsal for the day we chase one down in person. Whether the outcome is ordinary or transformative, the chase itself pushes instruments, sharpens global teamwork, and teaches the next generation to aim beyond yesterday's limits.
Look at this comet! Recently, it's erupted 4 times in less than 48 hours and has become nearly 300 times brighter than normal. This is the most powerful set of eruptions the comet has had in over 3 years. Should we worry here on Earth? Well, I wouldn't say scientists are worried. They're super excited. First, let me give you a little background. 29P is what astronomers call a Centaur comet. Those are icy objects that orbit the Sun in the space between Jupiter and Neptune. What's interesting about centaurs is that they're kind of like cosmic hybrids because they're moving from one kind of space body to another. They start their life as far-out objects in a lifeless, freezing cold zone beyond Neptune. But then, over a few million years, they move inward toward the Sun because the planets of the solar system affect them with their gravity. Eventually, they turn into short-period comets. This term means they can pass close to the Sun and then slingshot back out into those icy regions. Centaurs, and their name indeed comes from a hybrid half-horse, half-human creature popular in Greek mythology, are especially interesting because they're basically leftovers from the formation of our solar system, kind of like cosmic fossils. Since they've been hanging out in the frigid outer solar system for so long, they've kept a lot of the volatile materials that were present when the solar system was first forming. This makes them a valuable clue in understanding how our solar system evolved. That's what makes scientists so enthusiastic. Now, about 29P itself. This thing is huge for a comet. It's about 37 miles across, which is almost 3 times the length of Manhattan. Now, worry not, it's too far away to cause us any harm. While it's one of up to 1,000 known centaurs, 29P is also in a rarer group of comets called cryovolcanic comets. Those are a fascinating class of space objects that have unique geological activity. The thing is, cryovolcanic comets not only contain a unique mix of ice, dust, and rock, but also feature cryovolcanoes, aka cold volcanoes. They erupt with volatile materials like water, ammonia, or methane instead of molten rock. As for regular comets, when they approach the Sun, the heat from the star evaporates their gases, leading to the emissions of dust and tiny particles, electrons, and ions. These materials create those magnificent trails. These eruptions are incredibly spectacular and make the comet appear a lot brighter since the cloud of cryomagma reflects the Sun's light. The cloud that forms around the comet is called the coma, and it can grow so large and bright that it makes the comet look like a fuzzy ball of light. If you've ever observed a comet, the coma is the halo you see around it. Such eruptions are pretty unpredictable. While most cryovolcanic comets follow elliptical orbits that take them far out into the solar system, 29P is on a more circular orbit, staying around the same distance from the Sun as Jupiter. You'd think that this would mean its eruptions would be more regular, but that's not the case at all. In fact, 29P erupts in a completely random and unpredictable way, and scientists are still trying to figure out why. The latest outbursts started on November 2, 2024, when 29P erupted for the first time in almost 2 years. This was followed by 3 more large eruptions in less than 48 hours, which really got the attention of astronomers at the British Astronomical Association. They'd been tracking 29P for a while, and they reported that the eruptions sent out a cloud of debris reflecting about 289 times more light than the comet's nucleus, which is a huge increase in brightness. Astronomers are expecting that the coma, which is growing after each eruption, could take on an unusual shape. The multiple outbursts might cause the coma to expand in a weird, irregular way. This is especially interesting because 29P hasn't had a major eruption like this since November 2022. Then, it threw out over 1 million tons of debris. The last time it had a massive outburst was in September 2021, when the comet had multiple eruptions in quick succession. In addition to the confusion about its eruptions, 29P is pretty different from most other comets. Most comets have elliptical orbits that take them far out into the solar system. They spend decades, centuries, or even thousands of years far from the Sun, only to erupt when they get close. But 29P doesn't do that. No, it orbits the Sun once every 15 years and stays at about the same distance as Jupiter. This strange behavior makes astronomers even more eager to figure out what's going on with it. Another cool thing about 29P is that it doesn't ever get close enough to the Sun to grow a tail like other famous comets, such as the once-in-a-century comet, Tsuchinseng Atlas, which has recently made headlines. It passed the closest to Earth in 80,000 years. NASA's James Webb Space Telescope has been keeping an eye on 29P, helping solve some of the mysteries about the comet. And it has recently made another groundbreaking discovery. It has detected jets of CO2, good old carbon dioxide, coming from the comet. This was the first ever detection of CO2 jets on this particular comet. Webb has also discovered a jet of carbon monoxide coming from the comet. It can tell us a lot about the composition of the comet and its outbursts. What's especially interesting is that the jets seem to come from different parts of 29P's nucleus. Even though Webb can't actually figure out the nucleus itself because it's too small to see in detail, the jets coming from different locations on the comet's surface suggest that the nucleus may be made up of multiple objects. These objects might have different compositions, and it's possible that the nucleus is more of a composite body made up of smaller chunks that came together over time. Strangely, astronomers haven't detected any water vapor in the comet's atmosphere. That's unusual because the atmospheres of most comets often contain water. Our comet might lack water vapor due to the extremely cold temperatures on its surface. It could prevent water from evaporating or vaporizing. 29P isn't the only thing that Webb is studying. The telescope has also been making some big discoveries about galaxies far, far away. For example, Webb has recently spotted a galaxy with a pretty complicated name which appeared about 1 billion years after the Big Bang. What's super weird about this galaxy is that the gas in it is shining brighter than the stars, which is really rare. This could be a missing link phase in the evolution of galaxies, something that could help astronomers understand how galaxies transition from the very first stars, called population 3 stars, to the types of galaxies we see today. The stars in this galaxy are much hotter than we see in modern galaxies in local universe, around 144,000 degrees Fahrenheit, compared to the typical 72,000 to 90,000 degree Fahrenheit of stars today. This could mean that the galaxy is in the middle of a super brief but intense phase of star formation, where huge, hot stars are popping up in a dense gas cloud. And this gas cloud is glowing so brightly because it's being hit with tons of light from these stars. The research team behind this discovery says that although the galaxy doesn't have population 3 stars, because the data shows it has too much chemical complexity, it still could be a guide for understanding how galaxies evolved, from the first stars to the galaxies we're familiar with today. There are still so many questions about this galaxy. Is it a rare phase? Or is it something that happens often in the early stages of galaxy formation? Astronomers are hoping to study more galaxies like this one to figure it out. Living on our beautiful planet might seem safe, but only until you start thinking of all those dangers lurking just around the corner or in the vast darkness of the cosmos. Let's see what may eventually lead to the end of planet Earth. With each new potential threat, it gets more and more terrifying. Consider yourself warned. First of all, let's talk about hypercane. This natural disaster can get really extreme. A hypercane is a theoretical hurricane of unsurpassed power. It would occur if the ocean became overheated as a result of climate change, or a massive volcanic eruption could trigger it. In any case, these conditions would create a hurricane, which, unlike regular hurricanes, would stretch way beyond the lower stratosphere. The speed of such a storm would reach 500 miles per hour. The pressure inside the hypercane would be so low that it wouldn't let it wear out as quickly as other hurricanes. The hypercane could last for weeks on end. But the worst thing? It would likely damage or even destroy part of Earth's ozone layer, and the hole could be the size of the entire North American continent. Then we've got super destructive tornadoes. A tornado is a violently rotating column of air. It usually extends from a thunderstorm and is in contact with the ground. Inside a thundercloud, warm, humid air rises upward, and cool air falls down along with rain or hail. Such conditions can lead to the appearance of spinning air currents inside the cloud. Interestingly, these air currents start out horizontal, but at one point they can become vertical and drop down from the cloud, becoming a tornado. Some tornadoes are narrow, rope-like swirls, but others turn into wild funnels. Tornadoes are ranked with the help of the enhanced Fujita scale. A weak tornado normally lasts for a few minutes and doesn't move faster than 100 miles per hour. The next level is a strong tornado. Such whirlwinds can last for 20 minutes or so and have winds of up to 200 miles per hour. And then we can also have violent tornadoes. Those can last for more than an hour and move at a speed of between 200 and 300 miles per hour. On average, around 1,000 tornadoes occur in the USA every year. There's even a region that got named Tornado Alley. It's a 10-state area in the Midwest, but tornadoes can happen in any state. One of the most destructive natural disasters was the tri-state tornado in the USA. It was the world's longest-lasting single tornado that traveled 220 miles through Missouri, Illinois, and Indiana. At the same time, the average tornado's path is usually no longer than 5 miles. But what if one day, a tornado much bigger and way more powerful than any we've experienced before swiped through countries and continents? It would leave behind total destruction and devastation. And how about a supercell thunderstorm? It's the least common type of thunderstorm, but it's the most dangerous. It's likely to cause severe weather, damaging winds, very large hail, and even violent tornadoes. What makes supercells unique is a deep and persistent rotating updraft called a mesocyclone. Supercells can potentially last for hours and cause great havoc. An asteroid impact could end all forms of life on Earth too. If a space wanderer was large enough, it could cause widespread devastation, like it happened with the 9-mile-wide asteroid from 66 million years ago. It's rumored to have destroyed 3/4 of the planet's plant and animal species, including dinosaurs. Depending on the asteroid's size and the speed of its approach, the impact could lead to massive fires, tsunamis, and the eternal winter effect. It happens when the debris ejected into the atmosphere blocks sunlight and disrupts the global climate. Luckily, we'd probably notice such a large asteroid coming close to our planet with the help of our equipment long before the collision and would have enough time to get rid of this threat. It would be our very own sun that would bring our world to an end. Our star is a gigantic, constantly changing ball of molten gases. Every once in a while, it spews out bursts of energy, solar flares. They often go hand in hand with something called coronal mass ejections. Those are giant bubbles of ionized gas that can accelerate to incredible speeds. The most powerful volcanic eruptions pale in comparison to solar flares that release 10 million times more energy. Within a few minutes, one solar flare can give out billions of tons of charged particles. Solar flares are also insanely hot. with the temperatures reaching several million degrees Fahrenheit. Astronomers believe that such bursts of solar radiation happen when the sun's magnetic field gets twisted in some regions. At one moment, all the pent-up energy is released. The star sends out light and particles, mostly electrons and protons. Most solar flares last for minutes, but some continue for hours. Scientists classify solar flares depending on how brightly they shine in X-rays. You aren't likely to notice the tiniest flares if you don't have special equipment. Medium solar flares lead to fleeting radio blackouts at the poles, but nothing too serious. It's X-class flares people should worry about. They cause the strongest and longest-lasting solar storms. Now, if you had gamma-ray vision, you'd be able to see immensely bright flashes. They occur every day, outshine everything around you, and then disappear again. Those flashes are gamma-ray bursts. One of them could wipe out Earth's atmosphere. The flash that might ruin our planet would most probably be born in a faraway galaxy during a merge of two collapsing stars. It would be immensely powerful and super bright. Still 1,000 light-years from Earth, it'd already shine as bright as the sun. Our planet's atmosphere would try to protect us, but its natural shield wouldn't last. The radiation would be so powerful that it would literally cook the atmosphere. It would create nitrogen oxides that would destroy the ozone layer. Without this layer, ultraviolet rays coming from the sun would be hitting Earth's surface at full force. They would wipe out tiny plankton in the ocean. But these plankton produce from 50 to 70% of all oxygen in the world. So, with their disappearance, there would be a severe lack of oxygen, which would lead to the disappearance of life on the planet. In the end, the heat and ultraviolet light coming from the sun would turn the planet into a huge chunk of rock. And what if we came across a wandering black hole? You might know that a black hole is a region in space where gravity is so powerful that not even light can escape its clutches. Luckily, the nearest to us black hole is 1,500 light-years away. It seems that we have nothing to worry about until we learn about wandering black holes. Now, things definitely get way creepier. If such a black hole entered the solar system, Earth would be doomed. We wouldn't stand a chance against this space monster. In 2020, 13 wandering black holes were spotted not so far away from our planet. But not far away in space terms means around 1 billion light-years away, so we've got some time left. Plus, the possibility of such a disaster is very, very low. One day, a rogue planet might push Earth out of the habitable zone and into an extreme orbit farther from the sun. Then, the climate all over the planet would start getting colder and colder. Don't forget that the farther our planet is from the sun, the weaker the star's gravitational pull on our planet is. In the end, our beautiful Earth would get too far away from its main source of light and heat. It would turn into a lifeless piece of rock covered with a thick layer of ice. Or the sun might expand and turn into a red giant. If it happened, it would change the entire habitable zone of our solar system. The disaster would start with our star running out of hydrogen in its core. This would trigger a chain of reactions, which would eventually lead to the core of the sun heating up and getting denser. As a result, the sun would get way larger than it is now. During this transformation, the sun would swallow Venus, Mercury, and Earth.
The legend of the Black Knight satellite tells us that a spaceship of extraterrestrial origin has been orbiting Earth for many, many years. Sounds crazy, right? But over the years, the supporters of the theory have gathered a lot of evidence to prove it. So let's look at it and judge for ourselves. 1899. Famous scientist Nikola Tesla built a giant tower in his laboratory in Colorado Springs. This tower was supposed to allow him to study atmospheric electricity and wireless energy. Everything went fine until one day he discovered something unexpected. The tower began to catch a signal that seemed to be artificial. At first, Tesla thought that the signal was coming from somewhere in the atmosphere, but it turned out that it had been coming from an even greater height, from outer space. Tesla decided that this signal was sent by some extraterrestrial life. However, the scientific community ignored his theory. Although they respected Tesla's genius, they still considered him to be a weirdo. But a few years later, Tesla's reports were confirmed. The inventor of the wireless radio, Guglielmo Marconi, intercepted similar signals. Then in 1927, Norwegian radio engineer Jørgen Hoel noticed something unusual. When he sent signals at a certain wavelength, they were sent back to him a few seconds later. At first, he thought it could be an ordinary radio echo. It's not uncommon for short radio waves to bounce between Earth and the stratosphere. This phenomenon is called propagation. But usually it happens very quickly, in about 1/7 of a second after the original transmission. However, the signals that Hoel received took about 15 seconds to get back. They also didn't match the radio echo people were used to. The engineer wasn't the only one to witness this phenomenon. Many radio enthusiasts discovered and confirmed these signals, but no one found any explanation. So what was it? Could Tesla have been right this whole time? Let's unpack this. First of all, the signals did exist, and they've been documented by many people. However, Tesla and Marconi's signals and Hoel's echoes are completely different things. In reality, Tesla and Marconi caught signals coming from pulsars. Pulsars are rapidly rotating neutron stars. Those get born when stars greater than our Sun finish their life cycle. After that, they become neutron stars and receive such a strong impulse that they begin to rotate at an insane speed. At the same time, the radio waves pulsars emit reach very far as our planet. Pulsars were discovered only in 1968, so it's not surprising that Tesla and Marconi couldn't explain the data they had received. But what about Jørgen Hoel? What he discovered is now known as LDEs, or long-delayed echoes. It's a more complicated concept because, to be honest, these echoes still remain a mystery. Scientists suggest that LDEs may be caused by something in Earth's atmosphere, or they might be reflected from the Sun's plasma clouds or even from the Moon. Unfortunately, we don't know the truth yet. The next incident took place in 1960. The New York Times published an article which said an unidentified silent satellite has been discovered circling Earth in a near-polar orbit by United States tracking stations. The identity and origin of the mysterious satellite, which has been dubbed the Dark Satellite, are unknown despite nearly 2 weeks of tracking. Many people believe that this must be the famous Black Knight satellite. However, later scientists confirmed that it was actually the remnants of a regular satellite that had gone astray. It malfunctioned and the thrusters sent it in the wrong direction, they claimed. Anyway, this whole story led to renewed interest in the Black Knight satellite. Astronomers all over the world started claiming to have observed it. Almost any strange celestial object could become the famous dark spaceship. But up to this point, all the photos and data about the Black Knight satellite have come from observatories on Earth. To prove or disprove its existence, people needed some witnesses in orbit. Gordon Cooper was a pilot and one of the first astronauts in human history. In 1963, he took part in the longest American space mission at that time, Mercury Atlas 9. During the flight, he discovered some strange green object, possibly of extraterrestrial origin, in front of his module. He then told his crew on Earth about that. NBC News picked up on the news and tried to interview Cooper about it, but strangely, neither NASA's mission transcripts nor Cooper seemed to give much importance to this fact, as if that didn't happen at all. Later, the official NASA's explanation was there was an electronic malfunction on Cooper's craft. It led to increased levels of carbon dioxide, which in turn caused Cooper to hallucinate. Cooper agreed with this version. Maybe it's just a curious coincidence that when he retired, he became interested in searching for extraterrestrial life. But even if we assume that all this is true and there is some mysterious spaceship in Earth's orbit, what do they want from us? Why would they be watching us? In 1973, Duncan Alasdair Lunan, a Scottish researcher, decided to investigate this. He gathered all the data on LDEs collected by Norwegian scientists and began to study it. Suddenly, he noticed some deviations that could hide a code. He arranged the data into a graph, where one axis meant the delay in time between the echoes, and the other the position of the echo in the sequence. It turned out to be a collection of dots which looked like some sort of space map, namely the map of the constellation Warranties. Lunan began to analyze the echoes recorded by French astronomers in 1929. Again, he got the same constellation, but one of the stars was in a slightly different place. Lunan then thought, what if it's actually a star map from the past? After rewinding the time, Lunan finally got the whole picture. He discovered that this was how the constellation looked 13,000 years ago, which probably meant that they could have been watching us for thousands of years. In 1973, Lunan gave an interview to the British magazine Spaceflight. He said that he had deciphered the radio message hidden in the LDEs. Here is what it said. Start here. Our home is Upsilon Bootes, which is a double star. We live on the sixth planet of 7 coming from the Sun, which is the larger of the two. Our sixth planet has 1 moon. Our fourth planet has 3. Our first and third planets each have 1. Our probe is in the position of Arcturus known in our maps. Goosebumps. But even though these reports were published in the New York Times, Time, and other well-known magazines, no one really took this topic seriously. Unfortunately, Lunan's theory wasn't really backed up by any evidence. Later, he withdrew it himself, saying that he had made obvious mistakes and that his methods had been unscientific. According to him, he had just been making guesses about what these signals might mean. And finally, the last part of our story. This photo. On the 4th of December 1998, the Endeavour spacecraft embarked on the STS-88 mission. This was the first mission to the International Space Station. And then, on the 11th of December, NASA took and published a series of images where you could clearly see an unusual object in Earth's orbit. These photos were immediately picked up by the public. Everyone thought it was the Black Knight satellite, which had been discussed for years. Had it finally been found after 100 years of speculation? But as usual, the truth turned out to be much more boring. During the mission, one of the astronauts was installing a thermal cover, but the coating was poorly fixed. It broke off and flew away. The photos were taken just to document this event. The Black Knight is a very interesting legend. You can dig into it for hours, looking for new information and evidence, and then watch it getting debunked. This story is a pile-up of many completely unrelated stories, reports, photos of real satellites, and so on. All this was mixed into one incoherent, illogical urban legend. Illogical but very fascinating indeed.
So, we might be getting closer to finding a massive icy planet beyond Neptune's orbit. Sorry Pluto, still not you. Recently, some universe mapping using data from a telescope in Hawaii eliminated about 78% of the possible locations for this mysterious Waldo from space. Some people call it Planet 9, while others prefer Planet X. Either way, it's been causing controversy since its existence was first proposed. And that is mainly because no study so far can answer the big question: does it really exist? If discovered, Planet 9 would rank as the 5th largest planet in our solar system, with a mass 10 times that of Earth. It's also theorized to be gaseous, like Uranus. The initial study on Planet 9, dating back to 2016, suggests that this colossal new planet orbits the Sun 29 times farther out than Neptune, which sits at about 2.8 billion miles. As a result, the Planet 9 would take between 10,000 and 20,000 years to complete a single orbit around the Sun. If confirmed, this yet-to-be-understood world would dominate a region larger than any other known planet in our cosmic neighborhood. These are all intriguing hypotheses, but without a single piece of evidence or observation to back them up. Before dismissing this as a wild guess, it is important to note that these researchers relied on complex mathematical modeling and computer simulations to speculate about the planet's characteristics, because that's what they do. The hypothetical presence of this planet would explain various mysterious features located beyond Neptune. We are specifically talking about the Kuiper Belt, a huge donut-shaped region filled with icy debris left over from the formation of the solar system, including comets and dwarf planets like Pluto. What happens is that the 6 farthest objects in the Kuiper belt exhibit elliptical orbits that are all oriented in a similar direction within physical space and tilted approximately 30 degrees downward relative to the orbital plane of our 8 known planets. What's strange here is that, despite their distinct orbital velocities around the solar system, they maintain this alignment. The likelihood of such alignment occurring randomly is extremely low, around 0.007%. So here comes Planet 9, a hypothetical massive celestial body that offers a plausible explanation for this strange phenomenon, potentially exerting gravitational influence to shape these orbits. The initial theory didn't hold up for long, facing accusations of observational bias and calculation errors. Then, in 2017, another study popped up, sparking back the idea that maybe Planet 9 is out there after all. This time, Spanish astronomers tried a novel approach, focusing on observing extreme trans-Neptunian objects. These celestial bodies orbit the Sun in highly stretched elliptical paths, with average distances exceeding 13 billion miles. The research suggests that the distances between these objects' nodes and the Sun might provide clues to Planet 9's location. You see, these nodes are the points where a celestial body's orbit intersects the solar system's plane. When these objects reach these points, they're more likely to interact with other solar system bodies, potentially causing significant changes in their orbits or even collisions. So, if the trajectory of these extreme trans-Neptunian objects remains stable, everything's fine. But if it's not, well, that's a sign that something else, something big, is messing with their path. And that's exactly what the research found. There is something unseen out there, throwing these objects off course. And that something could be a planet, chilling at a distance between 300 to 400 times farther from the Sun than Earth. To this day, the study of the extreme trans-Neptunian objects is the strongest evidence we've got for Planet 9's existence. And if you're still not convinced by this theory, know that strange motions like these have led to planetary discoveries before. Neptune, for instance, was spotted because Uranus's motion didn't quite agree with the predictions of Newtonian gravity. But the deflection of its orbit could be explained if it was caused by a pull of an undiscovered planet. And just like that, we discovered Neptune. Now, the year is 2021, and there's all this buzz about Planet 9 again. After correcting some old guesses, studies are now leaning towards the idea that this mystery world follows an epic loop around the Sun every 7,000 years. That is massive news, because it means this planet might be closer than we ever thought, making it easier for our telescopes to spot it. The paper also suggests there is a whopping 99% chance that the funky orbits of these distant objects are all because of this unseen planet, not just some cosmic coincidence. Now, the odds of this whole situation being a fluke are down to a 1 in 250 chance, which is much better than the 1 in 10,000 chance back in 2016. All these optimistic numbers have brought us to where we are today, keeping our hopes and working on better equipment to continue the mission of spotting Planet 9. As mentioned earlier, researchers in Hawaii created some kind of treasure map utilizing the Panoramic Survey Telescope and Rapid Response System to eliminate 78% of its locations. This is great news, considering how challenging it is to find a planet-sized needle in a cosmic haystack. But unfortunately, Planet 9's presence remains a ghost in the dark outer reaches of our solar system. Enthusiasts are still convinced of its existence and believe it is only a matter of time before we celebrate the discovery of Earth's new cosmic cousin. They're putting their hopes on the Vera C. Rubin Observatory, which is currently under construction in Chile and is scheduled to begin science operations in late 2025. Over the course of 10 years, this observatory will scan the entire southern hemisphere sky every few nights with a 27-foot, fast-moving telescope equipped with the largest digital camera in the world. The idea is to catalog everything in the solar system, reaching out to and beyond Neptune, and tracking the movements of millions of celestial objects, including space junk, asteroids, comets, and stars. If Planet 9 is indeed out there, this next-generation telescope could be the one to find it. The existence of this mysterious planet is far from being universally accepted in the scientific community. That is simply because Planet 9 isn't the only explanation for the strange phenomenon occurring beyond Neptune. One theory suggests that a group of distant objects, such as dwarf planets, comets, and moons, might be collectively influencing the orbits of the extreme trans-Neptunian objects. Others believe that a black hole is behind all this. These compressed masses are some of the densest objects in the universe, potentially capable of affecting the orbits of other masses, like how this supposed ghost Planet 9 is believed to be doing. Another bold perspective suggests that our current understanding of the laws of gravity is flawed, actually incomplete. This theory, known as modified Newtonian dynamics, proposes that these distant icy objects exhibit strange behavior not due to influence from another planet, but rather because the immense gravitational field of the Milky Way is influencing them. However, even supporters of this theory acknowledge that it is too early to draw firm conclusions, and much more extensive research is still required. While we continue our relentless hunt for Planet 9, some astronomers have taken it a step further, suggesting the existence of a hypothetical Planet 10. This world has a mass and size like that of Mars or Earth and is located on the edges of the Kuiper Belt. But the thing is, if this alleged Planet 10 is indeed as small as scientists believe, it might not have enough gravity to clear its orbit of debris. And that is pretty similar to what happens with Pluto, being one of the reasons why it got into trouble back in 2006. So yeah, it's better not to get too excited. This supposed Planet 10 might end up classified as another dwarf planet.
Thousands of strange spaceships sneak into Earth's airspace. They descend to our planet and fly through cities, plunging people into complete chaos. Suddenly, the door of the largest ship opens, and a strange creature comes out. It tries to copy our language and says they had come from a distant star, Proxima Centauri. Something like this might happen because scientists have recently picked up a strange radio signal off that star. Proxima Centauri is the closest star to our solar system. It's only 4.2 light-years away. That means a beam of light that starts from this star reaches Earth in 4.2 years. That's also 270,000 distances from Earth to the Sun. The star Proxima Centauri itself is too pale for us to see with the unaided eye in the night sky, but its system hides a little secret. Let's fly there and take a closer look. So here's this red dwarf. It's 7 times smaller than our Sun and 8 times lighter. Proxima Centauri is 1.5 times bigger than Jupiter and almost 150 times heavier. But what we're looking for is a little further away. This is Proxima Centauri b, a planet similar to Earth. It's only 10% larger than Earth and is in the habitable zone of the star. It's the perfect distance, not too far away and not too close. So the temperature isn't too high or low there either. Water, if it exists on that planet, can be in a liquid state. And so, life can survive and evolve there. Maybe it's developed enough to send us the signal that we had received. A radio signal is basically waves. They have a certain frequency and length, and we can always tell an artificial signal from a naturally generated one. The signal that we picked up from Proxima Centauri b had a frequency of 982 megahertz. The regular radio we listen to in the kitchen or in the car picks up signals around 100 megahertz. That's why scientists have concluded that the signal was created artificially. Such signals could have a way of communication between the developed worlds. If this is really a message from an outer space civilian, we should be able to decode it. For this, any civilization must use the simplest method of encryption. For example, Earth has already sent a radio signal into space. It was the Arecibo message. This message consists of 1,679 digits. It's a rectangle of 23 by 73 squares that has information about our civilization encoded using a binary code. At the top of the rectangle, there's a system of numbers that we use. They're marked in white. This purple thing is the key to read the next part of the message. The atomic numbers of the elements like hydrogen, carbon, nitrogen, oxygen, and phosphorus are encoded in this key. These are the key elements that can start life. If those who receive this signal can make sense of the numbers in the key, they can read the next part of the message. These green things are the building blocks of our DNA chain, and right at the bottom here is the DNA chain itself. The white rectangle indicates the number of pairs of these building blocks, and the blue spirals show the shape of a DNA chain. And then we see the human silhouette itself. The white and blue object to its left is a coded number of our average height. The human itself is drawn here at the ends of the DNA strand, so that the outer space civilization can understand what we look like. And the white rectangle to the right of the human sketch is the number of Earth's population at the time of the message. That's 4.2 billion as of 1974, almost half the number we have now. The next part is a drawing of our solar system. The big yellow square is the sun. Then come all the planets in our solar system, including Pluto. Earth is shifted up a bit here, so that outer space civilization can understand where this message is coming from. In the last drawing is the observatory from which this message had been sent into space. This signal is now on its way to the M13 star cluster 25,000 light-years away from Earth, so it won't get there for another 25,000 years. And we'll need another 25 to get a response if there is really someone on the other side who can receive the signal. If the signal from Proxima Centauri is also a message, we'll need time to decode it. So let's fire up our super-powered computing machine and wait for the result. But this isn't the first mystery signal we've ever picked up on Earth. Scientists recorded an unusual wow signal in 1977. They supposed it came from somewhere in the constellation of Sagittarius. The telescope was picking up the unknown signal for an impressive 72 seconds. Later, a scientist who looked at the printout of the signal concluded that the signal was artificial. He wrote, "Wow," on the printout as his reaction. The following observations and studies couldn't catch this signal again. Some theories said that this signal came from a celestial spaceship flying by. It had flown away, and we could no longer detect the signal. But most likely, this signal was created on Earth. It was directed upward but reflected off an object at a high altitude. It could have been an airplane, a satellite, or space debris orbiting our planet. Then the signal was picked up by the telescope, and because it was human-made, all of its characteristics, like wavelength and frequency, could have confused scientists. In 2017, scientists recorded a flare on Proxima Centauri. The star's brightness increased by 1,000 times in just 10 seconds. Before that, there was another flare there that was weaker but lasted about 2 minutes. With these flares, Proxima Centauri has emitted enormous amounts of radiation. Even if there was life on the star's companion planet, these flares would have likely destroyed it. The stellar winds would have simply blown the atmosphere off the planet and made its surface lifeless. Overall, the planet Proxima Centauri b receives 60 times more high-energy radiation and 400 times more X-ray radiation than Earth. Scientists have concluded that the probability of life here is 1 to 100 million. And while we don't know yet for sure if the signal was artificial or natural, the scenario of a bunch of spaceships coming to Earth is most likely possible. Our only method for searching for outer space civilizations is using radio waves. They're like loud noise that blasts away from our planet in different directions at the speed of light. The main problem here is the gigantic distances. Our galaxy, the Milky Way, is 100,000 light-years wide. Suppose there's life at the other end of it. If we send a radio signal to them, it won't reach that supposed planet for another 100,000 years. And we won't get a response for another 100,000 years. It's the same if someone once wanted to contact us. We didn't learn how to create and receive radio signals until the 19th century. If a civilization was developing at the same time as us somewhere in the Milky Way and they invented the radio, we won't get their signal for several millennia. Plus, the radio noise from our planet is starting to fade away. We use Bluetooth, fiber optics, cable TV. So in about 100 years, we'll no longer be visible to other worlds. Or worse, what if there was an outer space civilization somewhere that was sending signals into space? The signals were reaching our planet, but we didn't yet have the technology to pick them up. The world that was sending the signal has evolved, and the signal went out. We could have caught those remnants of the radio waves that were moving through the universe, but we set up the antennas too late. There are about 2 trillion galaxies in the universe. Each of them contains billions and trillions of stars similar to our sun. Maybe there's a planet near one of them that looks like ours. Life could be blooming there. And this outer space civilization, just like us, is looking through telescopes in hopes to catch the radio signal from an unknown planet.
You know, many different things have nothing in common at first glance. The appearance of mysterious clouds over Stonehenge and the migration of wolves in Canada, patterns on the wings of a Caribbean butterfly, and strange footprints on the moon's surface. These are all random facts, but people can see connections in these events. Let's see how it can happen and where it can lead to. Imagine reading some crazy article on one of the unreliable sites, forgetting about it, and then beginning to notice small details in the world that might indicate that the information in this article is true. You realize you've learned something unusual, but for some reason, other people don't see it or don't want to see it. You try to tell them, but no one wants to listen to you. And some people even think you've gone mad. Let's stop for a moment and see what kind of article you've read. So, in 2017, one not-so-truthful site published a story about a ship from another planet called Black Knight that had been spying on people for 12,000 years. But not long ago, agents from a secret organization managed to destroy it. Sounds like absolute nonsense or a plot for a cheap sci-fi movie. Of course, you don't believe it. But a few years later, you find a story about Nikola Tesla. Let's fast forward to 1899. The famous scientist was sitting in his laboratory in Colorado Springs conducting radio experiments. Suddenly, his receiver caught a strange radio signal. Then, after a while, another one. The signals came in with the same time interval, as if someone wanted to send a message. Nikola Tesla realized it could be something from extraterrestrial civilizations that were trying to start a dialogue with people using the most universal language, math. He also reported about this event in a magazine at the beginning of the 20th century and added that he hadn't deciphered the message. Okay, now let's forget about it and see what happened next. In 1927, an engineer from Oslo, who was fond of radio devices, was sending signals into open space. He was surprised when, sometime later, the same signals began to return to his receiver. It was as if the signals bounced off something big and echoed back, or something received these messages and then sent them back to the sender to make an acquaintance. The man quickly reported his discovery to scientific journals, and perhaps someone connected this event with Nikola Tesla's words about strange signals from space. All this were just prerequisites for the Black Knight. But the most exciting events started decades later. In the 60s, Time magazine published an article that said that the U.S. had discovered a satellite orbiting Earth and using unknown technology. A couple of years later, Project Mercury astronaut Gordon Cooper reported that he had seen a strange object during his spaceflight. But the Black Knight became really famous only in the late 90s, when NASA published a series of images of a mysterious object. During the first flight to the ISS, astronauts noted weirdly shaped somethings and took several pictures. Then someone gathered all the facts, collected all the information about the black satellite, and discovered that it had been flying around our planet for more than 10,000 years. How did they figure it out? People managed to calculate the age of those radio signals that Tesla and the engineer had received. If this is true, the Black Knight appeared much earlier than the Sumerians in ancient Egypt. What if this satellite helped build pyramids and majestic temples? What if it had been watching over our development all this time and transmitting this information to another planet? What if mysterious images ancient people drew depicted the satellite? People began to suspect NASA and other space agencies of hiding information about the black object to prevent panic. And now, after having received all the data about the mysterious satellite, you might begin to suspect that the bizarre article may actually be true. This news is so improbable and ridiculous that no one will believe it. If you want to hide something, hide it in plain sight. And so, together with other enthusiasts, you start hunting for any information about the mysterious ship. You create forums, post photos of unknown objects, and become obsessed with this topic. You really believe in the reality of the Black Knight. Moreover, you don't want to question its existence. And people reading your articles do the same. Congratulations! You have become an ideal candidate for creating fake news in the yellow press. Such myths and urban legends seem attractive, The human brain feels pleasure when it finds fake secret information. The feeling of mystery, adrenaline, and shock can cause psychological addiction. That's why the stories about the Black Knight are still alive. Mysterious facts seem logical, and people stop seeing information that refutes their theories. The case of the Black Knight is no exception. The fans of this black object believe that Nikola Tesla received signals from some space civilization. But for some reason, they don't attach importance to scientific articles, which say that such radio signals could be sent by giant space objects like pulsars. A pulsar is a rotating neutron star emitting powerful electromagnetic radiation. Such radiation is often found in space. These radio waves don't imply the presence of a mind and a sender. The cosmos is full of such signals. The technology for detecting such objects were created in the 60s. Or maybe Tesla's device caught a signal coming from our planet. Besides, the scientists didn't say anything about the Black Knight. So why did people connect these two events? That story with the Norwegian engineer is still unexplained. Yes, his signals returned as an echo, but this had nothing to do with the flying object in question either. You might as well say that the satellite somehow influenced the Titanic. There's no logic in such assumptions. Strangely, no one connected the Black Knight with the Yeti or the Kraken. Now, let's return to that Times article about a strange object flying around Earth. It also stated it was a fragment of an American reconnaissance satellite. But fans of myths and legends apparently didn't notice this explanation. As for astronaut Cooper, who is said to spot some object during his mission, he actually saw nothing. He even showed a transcript with no reports about the black satellite. However, some believers in other civilizations keep silent about this fact. So, the main proof of the Black Knight's existence is the photos taken during the first flight to the ISS. The astronauts noticed this strange object and took pictures, but it wasn't a surprise for them because some part of the ship broke away during some work they did outside. It was a piece of thermal coating. The astronauts sent the photo to NASA, and the space agency assigned it a personal number, as it does with all such objects. A few days later, the Black Knight fell out of orbit and burned up in Earth's atmosphere. Almost all this information was recorded in official protocols. One of NASA's engineers, who knew the photographer of the black satellite, explained that those famous photos depicted an ordinary piece of the ship. There was nothing fantastic about it. But the fans of extraterrestrial rockets must have missed all this information. All these myths have long been debunked, and all the false facts have been refuted. But the Black Knight continues to live in many people's minds and on the pages of the Yellow Press. It has become a link between many reports of strange flying objects. Over the years, hundreds of stories have appeared about secret laboratories with extraterrestrial technologies, about NASA hiding secrets, and about creatures from other planets. And many people connected these myths with the black satellite. It has stopped being a real physical object. Now it's a cultural phenomenon. Remember how the main symbol of extraterrestrial civilizations was a flying saucer? It's not trending anymore. Today, the symbol is a black, weirdly shaped stone. Don't be fooled. Our solar system is full of mysterious objects that come from, well, everywhere. In October 2017, researchers in Hawaii spotted a mysterious thing that they dubbed a muamua. This means a visitor from a faraway land in Hawaiian. Or, that's a really big cow. It followed an escape orbit. It literally escaped from its planet's gravitational pull, like throwing a ball into space, never to return. This meant that this weird thing arrived from somewhere outside of our solar system. There were tons of theories about what it was, from a simple asteroid to an extraterrestrial spacecraft. Scientists even thought it was a chunk of nitrogen ice from a Pluto-like planet. Its strange shape only added to the mystery. The big changes in the light curves showed that this thing could be either elongated like a tube or more flat like a pancake. This thing was unlike anything we've seen before. Oumuamua didn't behave exactly like a comet or an asteroid. Comets are icy and form bright tails when they pass near the sun, while asteroids are basically just rocks and don't form tails. Oumuamua has no tail and doesn't release gas, like me. But it's not your average rock either. Its surface is very shiny, almost like polished metal. When it passed by the sun, it sped up, like it had a rocket on it. And it wasn't the sun's gravity that gave Oumuamua the sudden boost. Scientists aren't sure what caused it. So what in the world was that thing? After years of study, scientists now think that Oumuamua is probably a comet with frozen hydrogen on its surface. This hydrogen reacted with sunlight, speeding up the comet and changing its path. Oumuamua likely got all that hydrogen from being exposed to tons of cosmic rays for a long time. It got some nice red tint from them as well. Oumuamua was a visitor from a young, chaotic solar system where collisions and migrations happen all the time. Such systems often toss many small objects around. It might have been pushed out by a planet like Jupiter, whose gravity is so insanely strong that it can fling huge things into outer space. The same thing often happens with comets here. Oumuamua already left our solar system, although similar objects visit us sometimes, about once per year. To learn more about these mysterious guests, astronomers plan to send a probe to chase Oumuamua. We'll use Earth's and Jupiter's orbits to slingshot it fast enough to catch up with the comet. But some of the unexpected visitors stayed a bit longer. In October 2019, NASA's Hubble Space Telescope took a picture of a bluish comet trailing dust and gas. It was already in the solar system at the time, around 260 million miles away from Earth, somewhere between Mars and Jupiter. We saw the glowing dust surrounding it, but we couldn't yet see its nucleus since it's way too small. Well, small is relative here. The thing is about 3,200 feet across, which is like the length of 9 football fields. In March 2020, Hubble images showed that a small fragment of the comet broke away from the nucleus. That means that the comet is very active, unlike Oumuamua. As we observed it further, we found that the nucleus is a loose mix of ice and dust particles. Its surface is also very similar to others, with rough areas and smooth blankets of icy, dusty debris. The comet was discovered by an amateur astronomer, Gennady Borisov, so it got the name Comet 2I Borisov. Congratulations! Scientists quickly confirmed it came to us from outside our solar system. And this thing sure was an enthusiastic tourist. It traveled at a breakneck speed of about 110,000 miles per hour. That's fast enough to circle the Earth 4 times in just 1 hour. This visit was fascinating for several reasons. Most comets in our solar system come from the Kuiper Belt or the Oort cloud. The Kuiper Belt is a region of space beyond the orbit of Neptune. It's like a big, distant ring around the Sun, filled with many small, icy objects. All of them are ancient leftover pieces from the time when our solar system was still very young. The Oort cloud is much farther. It's like a giant bubble around the solar system, also filled with super old icy objects. Most long-period comets come from there. But where did the comet 2I Borisov come from? We still don't know for sure. Scientists say that it likely formed in another star system, which could be either younger or older than our solar system. Would be weird if there was a third option, NASA. Anyway, it might have been kicked out from its home system, just like Oumuamua. Although Comet 2I Borisov is too small to hold on to its own atmosphere, it developed a coma when it approached the Sun. Now, coma is a funny name for that beautiful glowing cloud of gas and dust that surrounds the comet's nucleus. It forms when the Sun's heat causes the comet's ice to vaporize, releasing dust and gas into space. This one was friendlier than Oumuamua and gave us some more time to study it. As a result, we learned more about its cool, unique traits. For example, it had never interacted with another star. But, unfortunately, Borisov had to leave too. Now it's on a path that will take it back into interstellar space. However, there are many more visitors to come, and you might have heard of this one. The Great Comet of 1996. That's what we call the comet Hyakutake. It was also named after the astronomer who discovered it, Yuji Hyakutake. In a beautiful coincidence, it was discovered on New Year's Eve. On March 25, 1996, this thing passed by incredibly close to Earth, only about 0.1 astronomical units away, a bit farther than the Moon. It passed over the North Pole. This made it one of the closest comet encounters in 200 years. It was visible worldwide, and it looked very bright and beautiful in the sky, stretching out widely. And it didn't stay for one night only. It got more and more visible during March, becoming one of the brightest objects in the night sky by the end of the month. The comet only fully faded by the end of May. It's a long-period comet, which means it takes hundreds of years to orbit the Sun. The last time it visited was about 17,000 years ago, and now its orbital period increased to 70,000 years. But don't be upset, there are other comets that will brighten our days and nights. Besides, some space objects prefer to stay around for longer. Now, there's this asteroid with a multisyllabic name that, to pronounce, is above my pay grade. This name in Hawaiian means the mischievous one of Jupiter. Luckily, scientists had mercy on us and dubbed it BZ. Hey, speaking for all the other narrators, thank you. It's a small asteroid, only about 1.8 miles in diameter. You can guess from the name that it shares an orbit with Jupiter. But there's a cool catch. The asteroid moves in the opposite direction, which is known as a retrograde orbit. The unusual asteroid was discovered on November 2014. It orbits the Sun for about 11 years and 8 months, sometimes passing inside and outside of Jupiter's orbit. It's been this way for at least 1 million years, and it will remain so for about 1 million more. But why does it move so unusually? BZ might actually be an interstellar immigrant. Perhaps it passed by our solar system about 4.5 billion years ago, around the time when the Sun was just forming. Then it got captured by gravity, but saved its opposite orbit. Or maybe it came from the Oort cloud. Then it could get its weird orbit from the mysterious planet 9, a hypothetical planet that's believed to exist in our solar system far beyond Jupiter. In any case, this asteroid gives us more insight into the history of the solar system and how organic materials can travel to us from outer space. Now, at any given time, there are thousands of objects in our solar system that come from outer space. They stay here for different lengths of time, but sometimes we get lucky, and they end up teaching us a lot about interstellar space. The very first known interstellar object, or ISO, to pay a visit to our solar system was a rocky, elongated interloper with a slightly reddish hue. It was spotted in 2017 and was dubbed with the Hawaiian name Oumuamua. It was almost 10 times as long as it was wide, and it was extremely unusual. Objects in our solar system are rarely shaped this way, so astronomers hoped it could provide some clues into how other star systems form and function. For hundreds of millions of years, longer than I've been around, this bizarre guest has been wandering through our home Milky Way galaxy, not bothering to settle down in some star system. And then, it came across the solar system. After the space traveler was discovered, hundreds and probably even thousands of telescopes all over the world, including ESO's Very Large Telescope in Chile, sprang into action. They started measuring the object's orbit, its color, and brightness. That's when it became apparent that the space rock had an unusual orbit. Some astronomers suggested that Oumuamua was emitting hydrogen it had picked up during its journey between stars. This was a simple explanation for the mystery that had evoked lots of outlandish theories. When this bizarre guest was first spotted upon entering the solar system, scientists were not sure what its nature was. Some claimed it was a comet. Others disagreed, saying it didn't have the features typical for comets: a visible long tail and a coma, which is a cloud of gases surrounding the nucleus of a comet. Plus, its shape was different from that of other comets. The only thing that made Oumuamua more comet-like was the way it accelerated as it went away from the Sun. The unusual object started to slow down on its way out, but in a strange way, as if not only gravity was in play there. It seemed like something was creating a force to counter this gravity. But unfortunately, this theory didn't quite fit either. The problem is that comets usually have large quantities of water ice on their surface, and as the Sun heats this ice, it gets ejected as jets of gas. Those jets act as mini rocket boosters. But Oumuamua not only had no tail whatsoever, but it was also too small to capture enough solar energy to support this kind of activity. Of course, this mysterious space visitor caused some more outlandish theories. For example, some people started to claim that Oumuamua could be a spacecraft sent by a civilization living in another star system. However, scientists found a better explanation. A comet that is traveling between stars gets cooked by cosmic radiation. These rays penetrate thick layers of ice, converting up to 25% of water molecules into molecules of hydrogen. And then, this trapped hydrogen gets released when some star warms the comet. The effects of this process are almost invisible. This might be the reason why we didn't see a spectacular tail accompanying Oumuamua. At the same time, the potential comet was so small that this could produce enough force to power its acceleration. As for the amount of ice released as Oumuamua was coming closer to the Sun, it was likely too small for astronomers to spot it. Now, even though Oumuamua was the first known interstellar object to enter our solar system, it wasn't the last. In August 2019, comet 2I Borisov visited us, becoming the second ISO astronomers managed to spot. Now, no one can argue that there simply must be more visitors from faraway star systems than those two. ISOs are rare, but our solar system is pretty old. It must have been capturing some interstellar travelers over the millions and millions of years of its existence, even though they never stayed for very long. One study has taken a closer look at interstellar objects, and they concluded that these space travelers might be caught not in solar orbits, but in near-Earth orbits. The astronomers working on this project even go as far as to claim that there might be a lot of ISOs in orbit around Earth. Now, finding tiny objects in the vastness of the cosmos is extremely tricky. Think about it. What images of distant areas of space do we usually get? Mostly stars. Sometimes unclear pictures of exoplanets. Even more rarely, it can be disks of debris. But fine detail in small space objects? Almost never. So it's actually lucky for us that other solar systems send their inhabitants to visit us. Because by studying ISOs, we gain insight into the formation, evolution, and functioning of other star systems. Have you ever heard of the Oort cloud? It's the most distant region of our solar system, and it's quite unusual. You see, the orbits of the planets lie mostly in the same flat disk surrounding the Sun. But the Oort cloud is believed to resemble a spherical shell surrounding the entire solar system. It looks like a gigantic, thick-walled bubble made up of chunks of ice and other space debris as large as mountains or even bigger. Astronomers think that the Oort cloud contains billions, if not trillions, of different objects. There might also be a connection between the Oort cloud and ISOs. Because scientists think that interstellar objects might outnumber those from the solar system in this region. Even though no one has ever observed the Oort cloud directly, astronomers are sure it does exist. They made such a conclusion after observing the distribution of comets in our solar system. The Oort cloud could have formed from debris in the early solar system, but some experts argue that the largest part of this unusual shell could be interstellar in origin. If travelers from other star systems are as common as some studies suggest, lots of the bodies on the edges of the solar system are likely to have originated in other systems. Sadly, this theory hasn't been proven yet. Now, since we've been talking about comets, not Cupid or Donder or Blitzen, one of them has recently approached the Sun at breakneck speed. It was 96P Mach-Holz 1. This comet is around 3.7 miles wide, and astronomers think it might have arrived from outside the solar system. The NASA European Space Agency Solar and Heliospheric Observatory spacecraft has been monitoring the comet. So look at this. That's the comet's tail. It's mostly made up of gas. It's trickling behind frozen chunks of ice that are getting heated by the radiation coming from the Sun. In some cases, a comet can have two tails, one made of dust and the other consisting of gas. And each of them can reach hundreds and, in some extreme situations, even millions of miles in length. In 2008, scientists analyzed the material left by 150 comets. They found out that the comet we're talking about was quite low in carbon and didn't contain a large enough amount of some other typical materials. This could only mean one thing. the comet was an interloper coming from another star system. It may have been ejected from its original solar system by the gravity of a large planet. After that, the poor homeless thing probably spent a large amount of time wandering around space, until it came across Jupiter. The gas giant could have bent the comet's trajectory, trapping it in orbit around the Sun. There's one more theory. According to it, the comet formed in a poorly studied region of the solar system, and it has this weird composition due to its repeated journeys around the Sun. Now, scientists are watching the comet with anticipation, like Christmas. Since it's an atypical one, both in its behavior and composition, they don't know what they will see, which makes the whole process even more exciting. Most comets falling toward the Sun are quite small, not more than 32 feet across. That's why they burn up as soon as they come close to our star. But the sheer size of Mach-Hulse 1, which is more than 2/3 the height of Mount Everest, seems to protect the comet from evaporating completely. You're standing next to a huge floor-to-ceiling window of the spaceship/wandering city you've been calling your home for a dozen years, along with a few hundred other people. You're watching a fascinating object nearing your spaceship, wondering if it'll bring an end to this journey and your life. It looks like an asteroid, but acts like a comet, moving as if something is pushing it. Can it be the engine created by another space civilization? Are you doomed, or are you about to have contact with a different kind of intelligence? Now, let's leave this post-apocalyptic fantasy and take a closer look at these space invaders called dark comets. The most intriguing question is obviously, what makes them move? Most likely it's some gas or material escaping from the surface of these space objects. Interestingly, until recently, no one has even been sure they existed. The first dark comet was discovered just a few years ago, and since then, researchers have identified 14 of them, including 7 new ones found just recently. The story of dark comets began in 2016, when scientists noticed something strange about an asteroid called 2003 RM. Its orbit wasn't quite what they expected. It had shifted slightly, and no one could explain that shift by typical asteroid behavior, when they received tiny pushes caused by sunlight heating an asteroid unevenly. Instead, the movement suggested that 2003 RM might have been releasing material, something comets often do. But there was a catch. The thing didn't look like a comet. There was no tail, no visible gas cloud. It was just a tiny dot of light, like a regular asteroid. At first, scientists thought 2003 RM was just a one-off mystery. But in 2017, a telescope spotted another strange object, this one from outside our solar system. It was Oumuamua. It too looked like an asteroid, but had a path that changed as if gas were escaping from it. The similarities between Oumuamua and 2003 RM made researchers think there might be more of such odd objects out there. By 2023, 7 more had been discovered in our solar system. These discoveries were enough to give this new type of object the name of dark comets. Now, scientists have enough data to start noticing patterns and learning more about their characteristics. And so, they have identified 2 main groups of dark comets. The first group, called outer dark comets, is larger, with sizes ranging from hundreds of feet to even more. They follow long elliptical orbits, similar to traditional comets that come from regions near Jupiter. The second group, inner dark comets, is smaller, usually tens of feet across. These comets move in almost circular orbits and stay closer to the Sun, near planets like Earth, Venus, and Mars. The main question these days is, where do dark comets come from? Can they be the remnants of larger bodies that broke apart? These space bodies could help us understand the history of the solar system. What if they had delivered the ingredients for life to early Earth? Once we study dark comets better, we might figure out if they contain materials like ice or organic compounds. And indeed, some researchers are sure that dark comets may contain or once have contained ice and played a big role in bringing water to Earth. According to a couple of studies, some asteroids in the asteroid belt, a region between Mars and Jupiter filled with rocky debris, might have ice beneath their surfaces, and this ice from the asteroid belt could have traveled into near-Earth space. In other words, It could be a pathway for water to reach our planet. So far, no one is saying that dark comets definitely brought water to Earth, but they might be another mechanism for moving ice from one part of the solar system to another. The study also hints at a connection between dark comets and a group known as Jupiter family comets. These are comets whose orbits are strongly influenced by the gravity of Jupiter, often pulling them inward toward the Sun. This connection makes it even more difficult to understand where dark comets come from and how they behave. Now, let's take a closer look at the differences between asteroids and comets. Traditional asteroids are rocky bodies that orbit relatively close to the Sun, typically within the ice line. This region is so close to the Sun that any ice on an asteroid surface would turn directly from a solid into a gas, leaving behind only rock. Comets, in turn, are icy bodies that form farther from the Sun. When they approach the inner solar system, their ice starts turning from a solid to a gas tube, creating a visible cloud called a coma or a tail while releasing dust and gas. Dark comets blur these definitions. They appear as rocky asteroid objects without a coma or tail, but they have behavior typical of comets, and that's small non-gravitational accelerations. These accelerations occur when ice turns into gas, giving the object a slight push. After analyzing 7 known dark comets, astronomers estimated that between 0.5% and 60% of all near-Earth objects might belong to this mysterious category. And since dark comets likely come from the asteroid belt, ice is likely to exist even in the regions of the belt previously thought to be too warm. Now, near-Earth objects like dark comets don't stay in the same orbit forever. The near-Earth environment is unstable, and objects typically remain there for about 10 million years. Since the solar system is over 4.5 billion years old, this means that new near-Earth objects must constantly replace those that are lost. Now, astronomers have used computer models to simulate the movement of objects under the influence of non-gravitational accelerations. They've traced the paths of these objects over a span of 100,000 years and discovered that many ended up in the same regions where we find dark comets today. Now, do you remember that space rock 2003 RM, which was the first to be called a dark comet? Well, it provided a particularly interesting clue. Its elliptical orbit brings it close to Earth, then out near Jupiter, before returning to Earth again. This trajectory matches what scientists would expect from a Jupiter family comet, an object that was likely knocked inward from its original orbit. Most of the other dark comets studied, however, seem to have come from the inner regions of the asteroid belt, closer to Mars. Dark comets are often small and spin rapidly. Astronomers often describe them as dirty ice cubes, all because these objects are a mix of rock and ice, and when they cross the ice line, their ice begins to turn into gas. This process not only causes those small non-gravitational accelerations, but also increases their spin rate. And the faster these objects spin, the easier they can break apart into smaller fragments. The pieces that break off also have ice, and as they spin faster and faster, they break into even smaller pieces. This process continues until you're left with very small, fast-spinning objects. This cycle of fragmentation helps explain why dark comets are often so tiny. But it could also mean there are more of them than we currently know about. The dark comet research provides new insights into the distribution of ice in the solar system and its potential pathways into the near-Earth environment. It also raises intriguing questions. For example, how much ice remains hidden in the asteroid belt? Or could dark comets have played a role in delivering water or organic materials to Earth? One of the most important points is that dark comets may represent a significant part of near-Earth objects. If it turns out to be true, it could mean that our understanding of the population of near-Earth objects and their potential risks for our planet is far from complete. The processes shaping dark comets, from sublimation to fragmentation, could be a major factor in the evolution of icy bodies throughout the solar system. Luckily, these days, scientists have an opportunity to combine advanced modeling with observations, which can eventually shed light on that very elusive class of objects that could have clues to the history of water and life on Earth.
A sound from space? When up there in space, no one can hear you talk, laugh, or scream. Or at least that's how the saying goes. People can't hear anything in space due to its condition. Still, if you have the right conditions, like the hot gas that surrounds the black hole located at the center of Perseus, space can be quite noisy. That's the galaxy cluster 250 million light-years away from us. Researchers caught an actual sound of space, waves rippling through the plasma gas in Perseus. They first realized black holes generate acoustic signals in 2003, but this is the first time they brought these signals to the human ear, and wow, this sounds terrifying. Canyons filled with liquid on Titan. Almost a decade ago, NASA spacecraft discovered deep canyons on one of Saturn's moons, Titan. They're about a half-mile wide and they kinda look like the Grand Canyon, but they're filled with liquid hydrocarbon. This was the first time we came upon evidence of canyons and channels filled with liquid on Titan. Our solar system is full of small particles and bigger rocks that circle the sun, the same way as planets. Sometimes it happens, some of them change trajectory, which is why falling pieces of debris strike the planets. Most of the meteorites and comets originate in our solar system. Some from the asteroid belt between Jupiter and Mars, while others come from the Kuiper belt, that's located beyond the orbit of Neptune. But 5 years ago, scientists found something unusual, a red, elongated floating space rock called Oumuamua. It could be more than 3,000 feet long, but its size still wasn't the most impressive part. It was the first interstellar object we saw passing through our solar system. It means it formed and came outside of it. It was traveling way faster than asteroids and comets from within our solar system. No one knows where this weird object came from. Many, many years ago, when it started its journey and sailed away from its parent planetary system, the stars weren't in the same position as they are today, so it's hard to pinpoint where Oumuamua ran away from. The rock could have been on its journey for billions of years. Solar termination events. Our sun is not just a flaming ball of gas we see in the sky. It's actually a pretty complex network of towering plasma fountains, magnetic fields, and blobs of unusual matter 500 times bigger than our own planet. And then there are solar termination events. When it comes to its activity, our sun goes through a natural cycle of troughs and peaks. Approximately every 11 years comes the time when the sun is more active than in other periods of the process. As the cycle goes to the end, there are fewer emissions and sunspots. That's because magnetic fields are weakened at that point, and they collide along the sun's equator. This results in enormous tsunamis of plasma. They pass across the solar surface for weeks. These are the most powerful storms in our solar system. They twist, snap, and lash out into space and seriously affect our power grid. As they wake, large spots start to form on the sun, close to strong magnetic field lines. Usually, that's when the cycle begins all over again. No one still knows why exactly they form. Also, we're not sure if this only happens at the end of the cycle, and knowing more about this could help us prepare for raging solar storms better. Tsunamis on Mars. It appears the shorelines under the Martian surface formed because of two enormous tsunamis. Mars has something that's probably the longest landslide in our entire solar system. The rocks rolled down the mountain probably billions of years ago. They fell into the water and caused a gigantic wave that rushed across the Martian landscape. As the tsunami was getting bigger, the rocks scraped all along the solid ground beneath them, and these sandy waves left their prints on the shoreline, not so close to Olympus Mons. That means it's possible the waves traveled a couple of hundred miles. This supports the theory that Mars once had an ocean hidden below its dry desert surface. Sure, Oumuamua was cool because it was the first object we've seen coming from outside of our solar system. It's past us now, so it's not possible to study it anymore. But something else came from outside our solar system after Oumuamua. A comet called Borisov. It came with a tail over 100,000 miles long. Teams got the first images of Borisov in 2019. A bright white glow was surrounding it. And that was one of the first signs where scientists realized this comet wasn't from our solar system. They tried to collect as much information as possible because they remembered how quickly Oumuamua got away. Borisov came from a freezing place as cold as the Kuiper Belt. One theory says it may have originated around a red dwarf, which is the most common type of star in our galaxy, the Milky Way. But unfortunately, Borisov was also very fast. So fast that they only managed to see it a couple of weeks before it passed by our planet. By now, it's almost out of our solar system. Finding new planets is always such a thrill, just like it was in 2017, when a group of researchers discovered Super Earth. It's an exoplanet, which means it orbits a star outside of our solar system. This one has a mass almost 3 times that of our planet, and it's only 21 light-years away. It orbits M-dwarf star, and it manages to make a full circle in only 2 weeks. So that's how long the year is on this planet. It's closer to its star than Mercury is to our sun. But M-dwarf stars are cooler than our sun, so it's possible this planet still has water. Super-Earth is generally a term for planets that are lighter than ice giants such as Uranus and Neptune, yet more massive than Earth. They can be made of rock, gas, or even a combination of both. The one they discovered in 2017 is especially interesting because this type of planet can also hold some form of life. Leroy Chiao is an astronaut who commanded the International Space Station back in 2005. This one time, during his final spacewalk, some pretty unusual lights caught his eye. It looked like 5 lights flying near him. They were in the shape of a pyramid, since one light was a bit further ahead. Chiao immediately called one of the crew members who was also out there at the same time, taking a spacewalk. He asked his colleague if he saw the flying objects, but apparently he didn't. Researchers were intrigued by this story, so they examined satellite images to see if that was the thing Chiao saw. One of the options was that Chiao had seen fishing boats off the coast of South America. With bright lights, they wanted to attract squid. But since it was twilight time, the rotation of our planet may have made them appear to fly by. Neutron stars slamming into each other. After a massive star comes to its end in a strong supernova explosion, its core falls apart. Then it forms the densest form of matter we know about in the whole universe, called a neutron star. In only a couple of the first few seconds after a regular star begins transforming into a neutron star, the energy there is equal to the total amount of light all stars in the universe emit. At least the part we can observe, which is still a lot. It's hard to determine their real size, but picture it this way. The length of Manhattan with 1.5 times the mass of the Sun. If a star here were any denser, it would just collapse and form a black hole. Scientists captured 2 of these stars colliding a couple of years ago, and such impacts are extremely powerful. They create gravitational waves that lead to a ripple in space-time, but they produce heavy elements like platinum and gold.
Let's do some quick math. A commercial airplane can fly at 575 miles per hour. Our rockets fly into space at 26,400 miles per hour. But this asteroid breaks all records and zooms at 33,000 miles per hour. That's 43 times faster than the speed of sound. At that speed, you could cross the Atlantic Ocean in just 5 minutes. The worst part is that this thing could crash into the Earth. This is asteroid 2021 RX-9. It's 120 feet wide. That makes it 1/3 the size of a football field. It was only recently discovered, and scientists were able to calculate its orbit. It's not round like most planets. It's an ellipse, like if you squeezed a donut a little bit. RX-9 begins its journey toward the center of the solar system, about 273 million miles from the Sun. It crosses the asteroid belt, then the orbit of Mars, and the orbit of Earth. It makes a circle around our star and then shoots back like a slingshot. The asteroid will move away from the Sun until the star's gravity forces it to begin its return journey. RX-9 makes one such round trip in 2.5 Earth years. Although the orbit of this asteroid intersects with that of our planet, it's not dangerous to us. The closest it'll get to Earth is 7.5 Earth-Moon distances. But there are many other asteroids in space. RX-9 could collide with them and change its trajectory. And that could put it on the list of potentially hazardous asteroids. And this thing is asteroid 2021 NY1, and it's already on the list. It's as big as 2 Statues of Liberty, and it's moving through space at 6 miles per second. So this asteroid could take you to the Moon in just 11 hours. Its orbit is also elliptical. Its far point lies somewhere between the asteroid belt and Jupiter, at 3.9 Earth-Sun distances. The closest point of its orbit to the Sun is right near the Earth's orbit. Asteroid NY1 has passed Earth at only 4 Earth-Moon distances. It'll make a circle around the Sun and head back to its starting position. The asteroid makes a complete orbit in almost 4 Earth years. The record for the closest approach to Earth belongs to asteroid 2020 VT4. It's a rock the size of a bus, and it flew at an altitude of 230 miles above Earth. For comparison, the International Space Station orbits our planet at 250 miles. So it literally flew over our heads in the region of the South Pacific Ocean. And we didn't even know this asteroid existed. It flew over the Earth at daytime, and we couldn't see it because of the sun's light. Scientists only learned about this asteroid 15 hours later. If it had fallen on Earth, well, let's say we could have had a very bad day. Although this asteroid was small, it was moving extremely fast. That gave it a tremendous amount of energy. But we have a shield that protects us from space rocks, our atmosphere. It's full of air particles. So when an asteroid enters our atmosphere, it begins to break against these particles because of friction. This heats up the asteroid so much that it begins to burn. This is the reason why the bottoms of our space shuttles were protected with black tiles. They could withstand temperatures up to 2,300 degrees Fahrenheit. So, if an asteroid is small, it could burn up completely in the atmosphere and turn to dust. If you look at it from Earth, it would look like a falling star. Scientists believe that any asteroid under 80 feet in diameter will burn up completely in the atmosphere and cause no harm. But an asteroid larger than 1.5 miles can do a lot of damage. And we know of such an asteroid that regularly passes by our planet. 4179 Toutatis. It's 3 1/3 miles wide, so it's bigger than Central Park in New York. And if you put this rock on scales, well, it'll show 5 + 11 zeros tons. That's heavy. The most frightening thing is that this asteroid moves in a chaotic orbit because it's constantly being affected by Earth and Jupiter. It's like the planets are playing ping pong with this giant rock. It also causes the asteroid to rotate like crazy. If you were on the surface of Toutatis, you would see that our Sun constantly rises and sets in completely different places. Because of this chaos, scientists can only predict the movement of this asteroid 50 years in advance. In 2004, it came within 4 Earth-Moon distances from our planet. Fortunately, there's a chance that one day it'll leave our solar system. Jupiter or Earth will launch it into distant space like a slingshot. But if it did fall to Earth, it would cause gigantic tsunamis and earthquakes all over the planet. Then the existence of our civilization would be in question. A similar catastrophe happened about 66 million years ago. At that time, I wasn't around then, but I heard about it. An asteroid the size of Manhattan flew toward Earth. The sun heated its surface and vaporized the material from it. The dust and steam turned into a giant tail that glowed brightly in the night sky. The night before it fell, it was the brightest object in the sky, perhaps even brighter than the moon. The moment this asteroid entered Earth's atmosphere, it caused a popping noise so powerful that you could hear it on the other side of our planet. It began to burn. Small fragments began to fall from the main body of the meteorite. Some of them burned up completely in the atmosphere, but others fell to the surface. The moment of impact, the mass and speed of the meteorite gave it colossal energy of about 100 teratons in TNT equivalent. That's a big boom. All this energy turned into heat. It was literally a wall of fire that spread around the impact site and burned everything in its path. The blast wave from the touchdown circled our planet several times. It caused a tsunami with waves higher than the Empire State Building, an earthquake so strong that the ground literally cracked. After this incident, about 95% of all life on Earth ceased to exist. The meteor left behind a crater as wide as 66 Golden Gate Bridges, and it was so deep you could stick 2 Mount Everests in there. And there are still many objects in the asteroid belt behind Mars that pose a threat to Earth. Like Ceres, it's not just any asteroid, it's a dwarf planet. Although it has a mass of only 1% of that of the Moon and is as wide as Texas, yeehaw, it gravitationally affects the orbits of Earth and Mars. A collision with an asteroid of that size would simply destroy the Earth, tearing it to pieces. So, humanity must learn how to avoid colliding with dangerous asteroids. Here, we have 2 options: destroy the asteroid or make it change its trajectory and fly past Earth. Destroying a huge rock that weighs as much as an entire city is difficult, so we stick with the second option. We can send a spaceship with explosive there and then do a little boom. Only we don't have to drill a hole to plant this present inside the asteroid. The boom has to be right above the surface and pointing upwards. Then, according to the law of physics, the asteroid will shift down a little bit. Even if the asteroid moves only a few feet, on a cosmic scale, this would dramatically change its trajectory. Another option is a gravity tractor. The principle is simple. Any object that has mass also has gravity, even you. Yes, you have your own gravitational force. So our plan is to send an unmanned spacecraft to the space rock. It would just have to hover over the surface of the asteroid. Then the space rock will attract the spacecraft, but the craft's engines will resist. As a result, the asteroid itself will start pulling toward the spacecraft. Voila! Earth is saved. We can also use solar power. All we have to do is build a giant space station out of thousands of magnifying lenses and send it to the sun. When we spot a dangerous asteroid, the station will focus the sun's rays on the surface of the asteroid. The ice from its surface will begin to evaporate and move upward. The reactive force will push the asteroid down. Or deliver a giant cloak of shiny material like foil to the asteroid. If you wrap the asteroid in such material, it'll reflect the sun's rays. Again, the rays are reflected one way and push the asteroid slightly the other way. This method can only work if we have a few years to spare before the asteroid arrives. Another strategy is to attach a solar sail to the asteroid. It would work like a parachute, only it won't be braking against the air, but against the sun's rays. And the simplest option? We could attach conventional rocket engines to the asteroid. Then we can not only change the trajectory of its flight, but also control it. And if a big asteroid appears on the horizon, we can use the controlled space rock as a giant ram. So you're standing on a diving board in the middle of an open space. You look down, but that's not a pool. It's a giant black hole. Well, what the heck? You start swinging and then you jump. The gravity of the black hole grabs you, and you pick up speed. Just a little more, and you'll enter the dark abyss. But you're not afraid. You're sure you can survive the fall into the black hole. Besides, you have a clear goal: to travel through time. But first, let's figure out how it works and why time stops near a black hole. This is the space-time grid. It's what our entire universe is made of. And just like a regular grid, it sags if you put something heavy on it, like me. For example, let's put the planet Earth here. You see a little funnel that is formed around the Earth, and if you put a small ball next to the planet, it'll roll into the funnel. That's how gravity works. The heavier the object, the more it bends space-time. By comparison, here's the Sun. It's almost 333,000 times heavier than the Earth, so it makes a really big funnel. So big that all the planets in our solar system move around that star inside that funnel. So now, let's put a black hole on a space-time grid. Its centers are infinitely heavy, so they create a limitless deep well. And anything caught in the black hole's gravitational field can never leave it, not even moving at the speed of light. Okay, their gravity is infinitely strong, but why do they slow down time? It's all about the speed of light. According to physics law, the speed of light must be the same at every point in our universe, even in a black hole. So, for our experiment, we take this ball, a photon of light that can travel 671 million miles per hour. You could get from Earth to the Sun at that speed in 8 minutes. That's how long it takes light to travel from our star to our eyes. So, when you're looking at the Sun, you're looking back in time 8 minutes ago. By the way, don't look at it directly. Now, the critical thing to remember here is that velocity consists of two physical quantities: space, miles, and time, hours. We'll use that later. Now, let's look at the black hole in our space-time grid. In three-dimensional space, it appears like this. But if we assume that space is two-dimensional, our grid looks like this when viewed from above, just a lot of squares. And this is the black hole right in the middle. If you look at the grid from the side, you'll see a straight line. And the black hole here looks like a pit, or like an endless well. Now, let's follow our photon of light in three-dimensional space. Here, it's moving toward the black hole, and then it falls into the well of the black hole, and it continues its motion at a constant speed. Now, the side view. Again, the photon moves from left to right and then falls. Its velocity doesn't change. The problems begin if you look at the experiment from above. When the photon of light moves in the distance of the black hole, its speed is stable. But then it goes down into the well. First, it slows down, and then it just stands still. But it's moving downwards. The photon moves in an arc down the well in the lower dimension without changing its speed. But in a higher dimension, it traveled a minimal distance at the same speed. Usually, this would mean that the photon was moving at a low speed in the second case, but not in the case of the speed of light. Remember, it must be the same at every point in the universe. The number 671 million miles per hour shouldn't change. So, we change the very parameters of that number, time. Time itself must slow down so much that this slight movement of the photon, when you look at it from above, was at the same speed, 671 million miles per hour. But if you go down and look at this well much lower, you see that its walls are almost vertical. So, a photon of light would be moving in a vertical trajectory. That means that if you look at it from above, the photon will just be standing still. Again, its velocity can't change, so time will vary. At that point, it should just stop. This is what happens near a black hole. Now, if you look at a black hole, you can see this effect in action. It swallows up the light around it. But as for an observer, it seems to you that the light stays in orbit around the black disk. In fact, at that moment, the photons are still moving at the speed of light inside the black hole. It's because time has slowed down there so much that you feel like the light has stopped there. This disk is called the event horizon, the point of no return, the last stop before you go into the black abyss. And at the very center of the black hole is the singularity. This point of space is so dense that if you tried to describe it with any numbers or physical quantities, they would all tend toward infinity. Simply put, all the laws of physics we know just stop working here. So scientists can't say exactly what awaits you in the singularity. Before you make that jump into the black hole, let's drop a space probe there with a blue light that flashes once per second, and let's attach giant clocks to it. You see the probe falling into the black hole, gaining speed, but then it starts to slow down. Moreover, the probe flattens out and seems to spread out around the black hole. And then you notice that the blue beacon on the probe has changed its light. It now flashes as red. It's because the light is a wave. Blue is a truly short wave with a high frequency, but the black hole's gravity acts on this wave, stretching it out. The light waves get lengthened and become broader and less frequent. The new wavelength and frequency match with the red color. It's called redshift. Also, the probe blinks now not once a second in short beeps, but lights up and goes out for a long time. It's because of the time warp. If you, as an observer, look at the clock on the probe, the second hand there barely moves. However, the clock on your hand works as usual. But if you could be in a black hole, time would seem normal to you, and the arrow on the clock would move as it did before. But the hands on the clock outside the black hole would move like crazy to you. That's because time goes much faster outside the black hole. Oops! Your probe just got ripped apart. That's because of the substantial difference in gravity that acts on the probe. The black hole's gravitational force increases with every foot of approach. That is, if you were to extend your hand toward the black hole hard, the gravity on your fingers would be much stronger than on your shoulder. This force would cause your fingers to lengthen, simply like spaghetti. That's why many people think it's impossible to survive falling into a black hole. But scientists think you could survive without a problem. Hey, maybe they should jump first just to make sure. The thing is, you have to pick a black hole as big as possible, like the ones at the centers of galaxies, for example. That bright spot at the center of the Milky Way also has a black hole. It's about 1 million times heavier than the Sun. And this is the Messier 87 galaxy, one of the most massive galaxies among our neighbors. In 2019, humanity got its first ever photo of the black hole at the center of this galaxy. It's about 6.5 billion times heavier than our Sun. So, it's the perfect place to make your jump into a black hole finally. Let's go. At first, you feel a strong acceleration as the incredible force of gravity grabs you. But in the case of a supermassive black hole like this, the gravity doesn't change as dramatically. That's because of its size. Right now, the gravitational force on your legs is about equal to the gravitational force on your head, so you don't turn into spaghetti, and you feel comfortable. You see that the light from the stars and all the space around you has begun to shrink at a certain point. It means that you have already passed the event horizon and are now moving toward the black hole's heart. As a result, the light of the universe becomes a small dot for you and then disappears altogether. If we look at our space-time grid, you're already falling into a well. Time is completely stopped for you. However, the rest of the world continues to move steadily through time. If you could now look at the Earth from a black hole, you would see a time-lapse, an accelerated video of how the months and years go by on our planet. If you had a jetpack that had an incredible engine to pull you out of the black hole, then you can make a jump forward in time. In 1 second, centuries on Earth could pass in the heart of a supermassive black hole. But this only works one way. You can't go back in time. But for now, you keep falling into the black hole. Beyond that, no one knows what'll happen to you. We only have theories about wormholes and white holes that might transfer you somewhere else in the universe. So, enjoy your trip, and just think about all the frequent flyer miles you're racking up. If an asteroid like Apophis hits Earth, we will be destroyed. Massive earthquakes will strike, and tsunamis will flood everything. Apophis is a billion-year-old celestial body that has been in the solar system since its inception. So you might be thinking, well, how likely is it that this giant space stone will collide with our planet in 2029? Well, let's find out, shall we? Apophis is a big, bad asteroid discovered in 2004 by the Kitt Peak National Observatory in Arizona. Since then, it has proudly held the title of one of the most dangerous asteroids ever located. It's around 1,100 feet wide, which is a bit bigger than the Empire State Building and the Eiffel Tower. Because of how scary it is, it was named Apophis, like the Egyptian immortal creature that was considered to bring eternal darkness and destruction to Earth. Oh boy. In 2021, researchers had a once-in-a-lifetime opportunity to study this floating rock when it passed near our planet, and we'll come back to that in a minute. Now, some scientists say that there is a small chance of Apophis hitting the Earth on Friday, April 13, 2029. The Yarkovsky effect is to blame for this, since it can slightly nudge this space rock towards Earth. This effect originates from the uneven emission of thermal photons from a rotating celestial object, resulting in a fascinating force exerted upon it in space. These emitted photons possess momentum and play a pivotal role in shaping the dynamics of the body. The asteroid has two sides, light and dark, just like the Moon. The light side faces the Sun and is warmer than the dark side. But the thing also turns, so the sides constantly change direction and temperature. This change could be detrimental because it slightly pushes Apophis toward Earth. Unfortunately, nobody knows how the Yarkovsky effect will influence the asteroid's path. On the other hand, on the asteroid's last flyby of Earth in 2021, Astronomers used radar to take accurate measurements of its trajectory and confidently concluded Apophis will safely miss Earth in 2029 by about 20,000 miles and won't bother us again for at least 100 years. Now, generally speaking, every 8,000 years, our planet is hit by a falling star that has similar dimensions to those of Apophis. The last time we were hit by a slightly smaller meteor was in 2013. A new spacecraft developed by NASA called the OSIRIS-REx was launched in 2016 to collect samples from another slightly less terrifying celestial body called Bennu. 4 years later, it finally arrived at the thing, got some samples, quickly said goodbye to Bennu, and started traveling back towards Earth. The samples were safely stored in a capsule dropped in Utah. So far, this has been the most significant sample ever taken from an asteroid. After the delivery, the spacecraft didn't waste any time and started chasing Apophis. Now, OSIRIS-REx has been renamed to OSIRIS-APEX, and is currently playing tag with Apophis. With some luck, on the 2nd of April 2029, when the asteroid zips close by Earth, the spacecraft will reach Apophis and land on it. It will stay on Apophis for 18 months, collecting valuable information and taking thousands of pictures. The asteroid will be monitored with the help of powerful telescopes. At some point, Apophis will get too close to the Sun, and then all the monitoring work will be on Osiris's apex back. If you live in Europe, West Asia, or Africa, you're one of those lucky people who will have a once-in-a-lifetime opportunity to see Apophis with the unaided eye. It'll be visible in the sky in these regions in 2029, and those who have telescopes will be able to spot it once again in 2036. OSIRIS-APEX will experience some problems because the asteroid has a thick crust, and the spacecraft won't be able to collect data as easily as it did with Bennu. OSIRIS-APEX has a unique thruster that will blow all the dust from Apophis while landing. This will be a perfect chance to analyze the surface of the asteroid to see what it's made of. The craft will spend 1.5 years mapping the asteroid, trying to detect changes in its shape. All this research will show how the celestial body is likely to move so we can better design plans to protect Earth from such things. In 2025, NASA is also going to launch the mission Apophis Pathfinder, and it will be the first spaceship to ever touch this asteroid. It will land approximately a year after its launch. Also, NASA has proposed sending a swarm of tiny craft into space to help humanity develop effective protective tactics against asteroid strikes. We know that Apophis originated in the primary asteroid belt between Mars and Jupiter. In the past million years, this celestial body has changed its path because of the considerable influence of Jupiter's gravitation. Now it seems like it favors the Sun more, meaning this asteroid will come very close to Earth. That's why it's classified as a near-Earth celestial body. A lot of tests and research have been done to find a way to deal with asteroids. Some solutions include drilling and detonating the space body from inside, or testing new technologies, like attaching rockets to it and trying to steer it away from Earth. We can also hit it with something moving at high speeds to make it change its course. Apophis is an S-type asteroid made of rocks and minerals like iron and nickel, and is shaped like a peanut. It can tell us a lot about the past and possibly the future. Sampling this space object could reveal how life on Earth began and how plants appeared. There are many theories that suggest that water arrived on our planet on an asteroid or a comet. Asteroids are like priceless time capsules. Unlike rocks on Earth, which have undergone thousands of changes, like erosion, most celestial bodies are still intact and much easier to study. When meteors fall on Earth, they get covered in debris that's impossible to clean. That's why studying Apophis while it's still in space is so important. Also, some asteroids are made of precious metals like platinum. Right now, we have a high demand for metals that we use in production, and mining metals on Earth is quite tricky. Just one large meteor might have iron, nickel, gold, and platinum that could last us millions of years. If Apophis has this amount of metals, Well, we'd want to break it down and bring it back to Earth. One space rock could be worth quadrillions of dollars, making space mining highly profitable. And still, it would cost us more to get it back to Earth than to dig up these materials here. As technology progresses and new kinds of rockets are developed, this might become possible at some point. So, even though we're safe for the next 100 years from Apophis, you probably still want to see what would happen if something like it did impact. Come on, sure you do. Well, first let me tell you, you'll hear the sound of the collision and know what's happened even if you're miles away. You should leave your house or apartment immediately. Shortly after the impact, massive earthquakes will strike, and many tall buildings will fall. So, staying away from cities might be your best option if you have a choice. But don't escape by car. There will be massive traffic jams, and everyone will panic. Going on foot or by bike is your best option in this scenario. A prime way of transportation will be traveling by plane, so if you've always wanted to get that pilot license, now you've got a good excuse. If you have time, take along extra snacks and water, and an extra pair of socks. It's nice to live by the ocean or the sea, but in this scenario, it's the worst place to be, because giant tsunami waves will hit coastlines after the impact. If you live far away from the impact area, the tsunami might take 30 hours to arrive. You'll have a bit of time to prepare.